Beneath your feet, beneath the soil and the stone and the silence of 4.5 billion years, the Earth holds a secret it has been trying to dissolve since before anything. With eyes existed to witness it, somewhere in the compressed darkness of ancient sediment, in a layer thinner than a human eyelash, there is a scar, a chemical whisper left by something that burned bright and then vanished so completely that even the rocks forgot its name. In 2018, two NASA-affiliated scientists asked a question that made the scientific world hold its breath. If a civilization had risen and fallen on this planet millions of years before us, would we even know? The answer they found was not comforting. It was not meant to be, because when they turned their instruments toward the deep geological past, searching for the fingerprints such a civilization would leave behind, they found anomalies, ancient disturbances in the rock that look hauntingly, disturbingly like what we are doing to this planet right now. Tonight, we descend through time itself, through scars in stone and temples older than farming, through maps drawn before their continents were discovered, and cities carved 18 stories into the earth, through the oldest stories humanity has ever whispered in the dark. If this channel brings you wonder and keeps you thinking, a like and a subscribe is the single best way to help us keep going. Now settle in, dim the lights, and prepare for a journey through the buried memory of a world beyond comprehension. We begin. There are questions that sit quietly at the edge of science, questions that researchers see but choose not to touch, not because the questions are silly, not because they lack merit, but because the answers, if they ever came, would shake the ground beneath everything we think we know. In 2018, two scientists decided to stop looking away. They reached out and grabbed one of those questions with both hands, and what they found still echoes through the halls of modern science, like a whisper that refuses to fade. Their names are Adam Frank and Gavin Schmidt. Frank is an astrophysicist at the University of Rochester. Schmidt is a climate scientist and the director of the NASA Goddard Institute for Space Studies. These are not dreamers hiding in basements, spinning wild theories by candlelight. These are mainstream, peer-reviewed, deeply respected scientists, the kind of people whose work shapes policy and fills textbooks. And the question they asked was so simple that it almost sounds innocent. Almost. If a civilization had existed on Earth millions of years before us, would we even be able to find it? Let that settle into your mind for a moment. Not the question of whether such a civilization existed. That is a different matter entirely. The question is sharper than that. It cuts deeper. Could we know? Is our science, our geology, our archaeology, even capable of detecting the traces of something that old? Because there is a massive difference between asking whether something happened and asking whether our tools could see it if it had. One question is about history. The other is about the limits of human knowledge itself. Frank and Schmidt gave their idea a name. They called it the Silurian hypothesis. The name was borrowed, with a knowing smile, from a 1970 episode of the British television show Doctor Who. In that episode, a race of intelligent reptilian beings called the Silurians is discovered to have lived on Earth hundreds of millions of years before humans ever walked upright. Frank and Schmidt were not claiming that lizard people built highways in the age of dinosaurs. They were doing something far more subtle and far more unsettling. They were testing the walls of what science can and cannot see. And those walls, it turns out, are much closer than we thought. Think about what our civilization leaves behind. Right now, today, we pour concrete and raise towers of glass and steel. We lay roads across continents. We fill the oceans with plastic. We pump carbon into the sky. We split atoms and scatter radioactive dust across the soil. We carve, we burn, we build, we discard. Surely, you might think, all of this would last forever. Surely some future species, millions of years from now, would dig through the rock and find our cities, our monuments, our garbage. Surely, we are too loud to be forgotten. But that is where the Earth plays its oldest trick, because this planet is not a museum. It is a machine, a slow, patient, grinding machine that recycles everything. Continents do not sit still. They drift, they collide, they tear apart. Oceans do not hold their shape. They open and close over millions of years. Mountains rise like fists from the crust, and then, grain by grain, are worn back down to flat plains. The ocean floor itself is not permanent. New crust is born at mid-ocean ridges, spreads outward, and is eventually pulled back down into the mantle at subduction zones, where temperatures and pressures melt everything back into magma. The oldest ocean floor on the planet is only about 200 million years old. Everything older has been swallowed and digested by the Earth itself. Now, picture our cities in that context. After a few thousand years, the buildings crumble, roots split the concrete, rivers change course and wash away the foundations. After 100,000 years, the rubble is buried under layers of soil and sediment. After 1,000,000 years, tectonic forces have shifted the land. After 10 million years, most of what we built has been compressed, dissolved, or dragged into the interior of the planet. After 50 million years, there is nothing left. No tower, no bridge, no highway, not even a recognizable fragment. The only things that might survive are chemical traces, thin layers of unusual elements in the rock, a spike in carbon isotopes, a dusting of synthetic molecules, plastics, rare earth metals, plutonium, wedged between layers of otherwise ordinary stone. Not a shout, a whisper, faint enough that a geologist might look right at it and see nothing more than a curious anomaly. A volcanic event, a methane burp, a natural fluctuation in ocean chemistry. This, it is what Frank and Schmidt realized, and it shook them, because here is the uncomfortable truth at the heart of their paper. We produce 300 million tons of plastic every year. We have detonated over 2,000 nuclear weapons, leaving radioactive fingerprints in ice and soil around the world. We have altered the carbon isotope ratio of the entire atmosphere. We have changed the chemistry of the oceans. We are driving species to extinction at a pace not seen since the asteroid that ended the dinosaurs. We are loud, we are messy, we are making a mark, and yet, given enough time, the Earth would erase almost all of it. If something intelligent evolved 50 million years from now, long after we are gone, they might find a thin, strange layer in the rock, a spike in certain isotopes, an odd concentration of metals. They would run tests, they would debate, and they would wonder what happened here. But they would not find our cities. They would not find our names. They would not find proof. Now, turn that lens backward. Look at the deep past. Look at the billions of years before us. And ask yourself the question Frank and Schmidt asked. Are there anomalies in the geological record? Are there moments in Earth's history where something happened that looks, from a chemical standpoint, like what an industrial civilization would do, where enormous amounts of carbon were released into the atmosphere in a short burst, where temperatures spiked without a clear cause, where the chemistry of the oceans shifted in ways that standard explanations struggle to fully account for? And the answer, quietly and stubbornly, is yes. Not everywhere, not often. But in specific moments in the deep past, there are scars in the rock that do not perfectly fit any single natural explanation. events that mainstream geology attributes to volcanism, or methane releases, or shifts in Earth's orbit. Explanations that are reasonable, that are probably correct, but explanations that, if you are being honest, leave a small door open. A door that Frank and Schmidt did not walk through, but that they pointed at and said, someone should at least look. They were very careful. They stressed, openly and repeatedly, that they strongly doubted any previous civilization had existed. They were not trying to prove one had. They were trying to map the boundaries of what we can and cannot detect. And the boundary they found was closer than anyone expected. Our ability to see into the deep past is limited. The record gets thinner and more fragile the further back you go. Vast stretches of Earth's surface from before the last 2.5 million years are simply not accessible. The evidence, if it ever existed, has been subjected to the most thorough destruction process in the known universe, the slow, relentless metabolism of a living planet. The Silurian hypothesis does not tell us that something was here before us. It tells us something, arguably more frightening. It tells us that we cannot be sure nothing was, and in science, that distinction matters, because the absence of evidence, it is not the evidence of absence, especially when the evidence would have been eaten by the very ground beneath your feet. So tonight, we do what Frank and Schmidt suggested. We look at the record, we search for the scars, and the biggest, deepest, most disturbing scar of all sits 56 million years in the past, waiting in the rock like a question no one has fully answered. 4.5 billion years. That is how old this planet is. You hear that number and you nod. You accept it the way you accept the distance to a far-off star. You understand it with your mind, but you do not feel it in your bones. Because the truth is, the human brain was never built to hold a number that large. We are built for counting seasons, for tracking the movements of herds, for remembering where the river bends. We are built for dozens, for hundreds, maybe thousands, but billions break something inside our sense of time. And yet, to understand the question we are chasing tonight, we have to try. So let us shrink it down. Let us take all 4.5 billion years of Earth's existence and compress them into something we can hold in our hands. A single day, the 24 hours, from midnight to midnight. One revolution of the clock to contain every volcano, every ocean, every creature, every extinction, every mountain range that ever rose and fell on this world. Midnight. The Earth forms, a ball of molten rock and metal, still glowing from the violence of its birth. For the first several hours of our imaginary day, the surface is a furnace. There is no water. There is no air you could breathe. There is nothing alive. Around 4 a.m, the first simple life appears. Single-celled organisms, tiny, quiet, invisible to the naked eye. They will remain the only life on this planet for a staggeringly long time. Hour after hour after hour on our clock, nothing changes. Just microbes, drifting in ancient seas under a sky that would poison you in seconds. Complex life, the kind with bodies and organs and eyes, does not show up until sometime around 9 in the evening. 9 in the evening. Think about that. For more than 20 hours of our 24-hour day, the most complex thing alive on Earth was a single cell. All the animals, all the plants, all the forests and reefs and ecosystems you have ever seen or imagined, they belong to the final few hours. The dinosaurs arrive around 11 at night. They dominate the planet for roughly 45 minutes of our compressed day, 45 minutes of roaring, thundering, extraordinary life. Then, at about 23 minutes to midnight, an asteroid strikes the Yucatan Peninsula and wipes them out. Just like that, 45 minutes of dominance ended in a flash. And us, Homo sapiens? We appear at roughly 4 seconds before midnight. 4 seconds. Everything we have ever done, every city we have raised, every language we have spoken, every war we have fought, every song we have sung, every equation we have solved, every rocket we have launched, all of it fits into the final 4 seconds of a 24-hour day. Now take civilization, not our species, just our civilization. Agriculture, writing, permanent buildings, organized society. That begins roughly half a second before midnight. Half a second. The Great Pyramid, the Roman Empire, the invention of the printing press, the moon landing, the phone in your pocket, all of it in half a second. A blink, a heartbeat of the clock. And here, inside this impossible smallness, is where the question begins to burn. If intelligence, if the spark that drives a species to build and wonder and reach, if that spark only needed half a second to go from stone tools to satellites, then what about all those other hours? What about those long, dark stretches of time when complex life existed, but we were nowhere to be found? Complex animals have roamed the earth for over 500 million years. That is more than 3 hours on our compressed clock. Mammals have been around for over 200 million years. That is more than an hour. And the dinosaurs, those magnificent creatures that we tend to think of as slow and simple, they had 165 million years. Some of them had large brains relative to their body size, and some lived in social groups. Some showed signs of problem solving. Some cared for their young in ways that suggest emotional bonds. They had 45 minutes on our clock. We have had 4 seconds, and in those 4 seconds, we went from chipping rocks to splitting atoms. What could 45 minutes produce? This is not fantasy. This is mathematics. This is probability. And it is a probability that most scientists have been quietly uncomfortable with for a very long time. Because the standard answer, the safe answer, is that intelligence happened once. That consciousness, language, technology, the drive to build, all of it is a freak accident. A one-time lightning strike in a 4.5 billion year storm. We are special. We are unique. It only happened once, and it happened to be us. And maybe that is true. Maybe we really are the only species in this planet's entire history to look up at the stars and wonder what they are. But there is a quiet voice in the back of the room, the voice of deep time, that says the odds of that seem very small. Consider the conditions. For intelligence to evolve, you need a few basic things. You need a planet with stable conditions over long periods. Earth has that. You need an atmosphere with enough oxygen to support complex metabolism. Earth has had that for hundreds of millions of years. You need diverse ecosystems that create competitive pressure, the kind of pressure that rewards cleverness, adaptability, cooperation. Earth has had that in abundance. You need time. And time is the one thing Earth has more of than anything else. The ingredients have been sitting on the counter for hundreds of millions of years. We are being asked to believe that the recipe was only followed once, in the very last moment, in the final fraction of the final second. There is a concept in science called the mediocrity principle. It says, simply, that there is nothing special about our position in the universe unless evidence proves otherwise. We are not at the center of the solar system. We are not at the center of the galaxy. We are not at the center of the cosmos. Each time we assumed we were special, science proved us wrong. The mediocrity principle suggests that we should not assume our moment in time is special either. That intelligence arising once, exactly now, after billions of years of opportunity, would be the exception, not the rule. None of this proves that something came before us. Probability is not proof. A coin can land on heads 100 times in a row, and it does not violate any law of physics. But probability does tell us where to look. It tells us which assumptions deserve to be questioned. And the assumption that 4.5 billion years of planetary history produced exactly one flash of intelligence, right at the very end, in the very last tick of the clock, is an assumption worth questioning. The dinosaurs had 165 million years. Some species of dinosaur lasted longer than our entire genus. The troodontids, small bipedal dinosaurs with large brains, forward-facing eyes and grasping hands, lived during the late Cretaceous period. Paleontologist Dale Russell once speculated about what might have happened if the asteroid had not struck. If the troodontids had been given another few million years of evolution, could they have developed intelligence? He even created a thought experiment, a hypothetical creature he called the dinosauroid, an upright, large-brained descendant of Troodon. It was controversial. Many scientists dismissed it as too speculative. But the underlying point was serious. The raw materials for intelligence existed long before we did. The question is whether they were ever assembled. And that question, that haunting, elegant question, leads us to the next part of our journey. Because if something did rise and build and think before us millions of years in the past, what would it leave behind? What could survive the grinding, dissolving, recycling machinery of a planet that eats its own history? The answer is almost nothing. Almost. But almost is not the same as nothing. And in the rock beneath our feet, there are traces. Faint, ambiguous, debatable traces. The kind of marks that could be natural, the kind that probably are natural, but the kind that, if you know what to look for, carry the faintest ghost of something else. Imagine that tomorrow morning. Humanity simply stops. No war, no plague, no asteroid. We just vanish. Every person on Earth gone between one heartbeat and the next. The coffee is still warm on the counter. The traffic lights still change from red to green. The satellites still orbit overhead, circling a world that no longer has anyone watching the screens. What happens next? And more importantly, what would be left of us after the Earth has had a few million years to clean up? The answer is a story of slow, patient destruction. A story that begins with weeds and ends with silence. Within the first few weeks, the power grids collapse. Most power plants require constant human management. Without it, they shut down or fail. The lights go out across the world, one city at a time. Within months, nature begins its invasion. Grass pushes through cracks in the pavement. Vines crawl up the walls of office buildings. Roots, those quiet, relentless fingers of the forest, begin splitting concrete from below. Water seeps into every opening that was once sealed by human hands. Freeze and thaw cycles crack foundations, shatter windows, split roof lines. The buildings we thought were monuments begin to rot. Within a few decades, most wooden structures have collapsed. Termites, fungi, and moisture have eaten them from the inside out. Steel structures last longer, but not by much. Without paint, without maintenance, without the constant human effort to hold back corrosion, steel rusts. Bridges sag. Skyscrapers groan. The bones of our cities begin to fold in on themselves, like dying flowers. Within a few centuries, almost every structure above ground is gone, reduced to mounds of rubble, slowly being swallowed by soil and vegetation. The great dams crack and release their rivers. Coastlines reshape themselves. Forests reclaim the land we cleared. From the air, if anyone were watching, the last traces of our roads and parking lots would look like faint scars on a healing skin. and then even those would fade. Within 10,000 years, almost nothing recognizable remains on the surface. A few stone structures might survive. The pyramids of Giza, carved from massive limestone blocks in the driest desert on Earth, might still be visible as weathered mounds. But most of what we built, the glass towers, the shopping malls, the highways, the factories, would be indistinguishable from the landscape around them, buried under layers of sediment, dissolved by rain, scattered by wind. Now, push the clock further. 100,000 years, 1,000,000 years, 10 million years. At these timescales, the Earth itself changes shape. Tectonic plates continue their slow dance. Continents drift. New mountains are pushed up where plains once stood. Old mountains are worn down to nothing. Rivers carve new valleys and abandon old ones. The coastlines you know today are gone, replaced by shapes no human eye has ever seen. Glaciers advance and retreat, scraping the land clean like a carpenter's plane across rough wood. Volcanic eruptions bury entire regions under fresh rock, and the ocean floor, with that vast dark carpet covering 71% of the planet, is not permanent either. It is a conveyor belt. New crust forms at mid-ocean ridges where magma rises from the mantle and solidifies. That crust spreads outward, carrying everything on it: sediment, shells, the chemical record of whatever happened in the water above. And at the far end of the belt, at the subduction zones where one plate slides beneath another, the crust is pulled down into the mantle and melted, recycled, erased. The oldest ocean floor on Earth is about 200 million years old. Everything older has already been swallowed. So if a civilization existed, say, 50 million years ago, what physical evidence could possibly remain? Not their buildings, gone. Not their roads, gone. Not their tools, their machines, their art, their books, all gone. Compressed into thin layers of sediment, chemically broken down, atoms scattered and recombined into new minerals, new rocks, new landscapes. The very molecules that made up their world have been reshuffled so many times that no instrument on Earth could reassemble them into a recognizable form. Even fossils, those precious stone memories of ancient life, are staggeringly rare. The conditions needed for fossilization are specific and uncommon. An organism must be buried quickly in the right kind of sediment, in the right chemical environment, before decay and scavengers destroy it. The dinosaurs dominated the planet for 165 million years. Billions upon billions of individual dinosaurs lived and died across that span, and the total number of reasonably complete dinosaur skeletons ever found is small enough to fit inside a single building. Most species that have ever lived left no fossils at all. They existed, they thrived, they vanished, and the rock remembers nothing. A civilization lasting a few thousand years, occupying a small fraction of the Earth's surface, would be astronomically unlikely to leave even a single fossil. No bones, no skulls, no trace that anything with a spine ever held a tool or looked up at the moon and wondered. So what could survive? What signal could possibly persist through 50 million years of tectonic grinding, chemical dissolution, and geological recycling? The answer, and it is a thin and fragile answer, is chemistry. Not objects, not shapes, not structures, but chemistry. The invisible fingerprints left behind when you change the composition of the atmosphere, the oceans, or the soil on a massive scale. Right now, our civilization is leaving exactly these kinds of fingerprints. We produce roughly 300 million tons of plastic every year. Microplastics have spread to every corner of the globe, from the deepest ocean trenches to the peaks of the Himalayas. We have detonated over 2,000 nuclear weapons, scattering radioactive isotopes like plutonium-239 into soil and ice on every continent. These isotopes do not exist naturally in significant quantities. Their presence is a signature, a chemical fingerprint that says something unnatural happened here. We have also changed the isotopic ratio of carbon in the atmosphere. When you burn fossil fuels, coal, oil, natural gas, you release carbon that has a specific isotopic signature. It is lighter than the carbon released by volcanoes or ocean processes. Scientists can measure this difference. It shows up in ice cores, in tree rings, in ocean sediments. It is a mark that says someone was burning ancient carbon. Someone was digging up the dead and setting them on fire. If our civilization ended today and something intelligent arose 50 million years from now, they would not find our cities. But if they drilled deep enough, if they pulled the right core sample from the right location, they might find a thin, strange layer in the rock. A layer with an unusual spike in carbon-13 depletion. A layer with traces of plutonium where there should be none. A layer with an odd concentration of rare earth elements and synthetic molecules that do not match any known natural process. They would stare at it. They would run tests. They would argue about what it meant. And most of them would probably conclude it was a volcanic event, a methane release, a natural anomaly. Because the chemical signatures of an industrial civilization, after millions of years of dilution and transformation, look almost exactly like the signatures of certain natural events. This is the cruel heart of the problem. The signal we would leave behind is real, but it is ambiguous. It whispers, but it whispers in a language that sounds like the Earth's own voice. And unless you already suspected that something unnatural had happened, you would have no reason to listen for it. Frank and Schmidt understood this perfectly. They were not saying that the rock contains proof of a lost civilization. They were saying that the rock could contain such proof, and we might never recognize it. Our tools are sharp, but the disguise is nearly perfect. The chemical residue of a civilization and the chemical residue of a volcanic episode sit side by side in the periodic table, wearing almost identical masks. And yet, when you turn the lens backward and look at the deep geological past, there are moments where the rock tells a story that does not quite fit the standard explanations. Moments where enormous amounts of carbon were released into the atmosphere in bursts that seem too fast, too concentrated, too chemically specific to be easily explained by any single natural cause. The most dramatic of these moments has a name. It happened 56 million years ago. It left a scar so deep that every sediment core from that era, pulled from oceans and ice fields around the world, tells the same unsettling story. And it is waiting for us now, buried in the next layer of stone, patient and silent and impossible to ignore. 56 million years ago, something happened to this planet that science still cannot fully explain. It was not a meteor. There is no crater. It was not a single volcanic eruption. No caldera on Earth is large enough to account for what the rock reveals. It was something else entirely. Something that arrived fast by geological standards, burned through the system like a fever, and left a mark so deep and so consistent that every core sample from that era, whether pulled from the floor of the Atlantic Ocean or drilled from Arctic permafrost, tells the same disturbing story. The world caught fire, not with flame, with heat. Scientists call it the Paleocene, Eocene Thermal Maximum, the PETM. It does not get talked about much outside of geology departments and climate laboratories. But it should, because the PETM is one of the most extraordinary events in the last 66 million years of Earth's history, and it carries a feature that once you understand it, sits in your chest like a stone you cannot swallow. It looks exactly like what our civilization is doing to the planet right now. Here is what the rock tells us. Approximately 56 million years ago, over a period of roughly 6,000 to 20,000 years, an enormous volume of carbon was released into the Earth's atmosphere. The estimates vary depending on the study, but current research suggests somewhere between 3,000 and 13,000 petagrams. A petagram is 1 billion metric tons. To put that in perspective, humanity has released roughly 580 petagrams of carbon since the Industrial Revolution began. The PETM released at minimum 5 times that amount, possibly as much as 20 times more. And it happened fast, not fast by human standards, but blisteringly, terrifyingly fast by the standards of geological time. The result was a planet transformed. Global average temperatures rose by 5 to 8 degrees Celsius. That may not sound dramatic until you understand what it means in practice. The current global conversation about climate change is focused on preventing a rise of 1.5 to 2 degrees. 5 to 8 degrees is not a warmer version of our world. It is a different planet entirely. During the PETM, the Arctic Ocean reached temperatures of 23 degrees Celsius. That is 73 degrees Fahrenheit. Subtropical waters lapping against shores of ice that no longer existed. Off the coast of what is now Antarctica, ocean temperatures hovered around 20 degrees. The poles were warm enough for palm trees. Crocodile relatives lived above the Arctic Circle, basking in warmth that had no business being there. Meanwhile, the tropics became a furnace. Ocean surface temperatures off the coast of West Africa reached 36 degrees Celsius, 97 degrees Fahrenheit. At that temperature, many marine organisms simply cannot function. Their proteins begin to break down. Their metabolisms collapse. They die. The deep ocean suffered worst of all. As carbon dioxide dissolved into the water, the oceans became more acidic. Shell-building organisms, corals, and creatures that depend on calcium carbonate structures were devastated. Their shells literally dissolved in the acidifying water, and the deep sea lost much of its oxygen. The technical term is anoxia. In plain language, it means the bottom of the ocean suffocated. Creatures that had lived on the deep sea floor for millions of years died in enormous numbers. It was the largest deep-sea mass extinction event of the last 93 million years. On land, the effects were equally violent. Rainfall patterns shifted dramatically. Regions that had been lush dried out and cracked. Others were hammered by storms of unprecedented intensity. The fossil record from the Bighorn Basin in Wyoming, and in one of the most detailed terrestrial records of the PETM, shows that the entire mammalian community turned over. Species that had existed for millions of years vanished. New species appeared. The landscape was reorganized from the soil up, as if someone had reached down and shuffled all the cards. And then, slowly, over the next 100 to 200,000 years, the Earth healed. Carbon was drawn back down into the oceans and the rock. Temperatures fell. The chemistry of the seas rebalanced. Life adapted, diversified, and moved on. But the scar remained. A thin band of unusual chemistry sandwiched between layers of ordinary sediment. A geological whisper that says something extraordinary happened here. So what caused it? This is where the story becomes truly interesting, because the honest answer is that no single explanation accounts for everything we see. The most widely supported hypothesis involves massive volcanism. Around 56 million years ago, Greenland and Europe were tearing apart. The North Atlantic Igneous Province, a region of intense volcanic activity, was pouring enormous volumes of magma into the crust. Some of that magma intruded into carbon-rich sedimentary rocks, essentially cooking them and releasing vast quantities of carbon dioxide and methane into the atmosphere. Mercury anomalies found in PETM-era sediments support this idea, since mercury is a reliable chemical proxy for volcanic activity. A second hypothesis points to methane hydrates. These are ice-like structures buried in deep-sea sediments that trap enormous amounts of methane, a greenhouse gas far more potent than carbon dioxide in the short term. If ocean temperatures rose even slightly, these hydrates could have destabilized and melted, releasing their methane in a runaway cascade. A little warming triggers methane release. The methane causes more warming. More warming releases more methane. A feedback loop spiraling upward with no break. A third hypothesis involves orbital forcing. Changes in the Earth's orbit, specifically in its eccentricity and precession, alter how much solar energy reaches different parts of the planet. Recent research suggests the PETM onset coincided with an extreme in orbital precession during a period of maximum eccentricity, meaning Earth was receiving an unusually strong dose of solar energy. This could have been the initial push that set the cascade in motion. Most scientists today believe the PETM was caused by a combination of all three. Volcanism provided the initial carbon pulse. Orbital forcing amplified the warming. Methane hydrate collapse kicked the system into overdrive. Together, they explain most of the observed data. Most of it, but not quite all. And here is the detail that sits at the very edge of the conversation. The detail that Frank and Schmidt highlighted without making claims they could not support. The carbon isotope signature of the PETM does not perfectly match any single natural mechanism. The ratio of carbon-12 to carbon-13 in the sedimentary record shows a sharp negative shift at the PETM boundary. This shift is consistent with the release of biogenic carbon, meaning carbon that originally came from living things. Fossil fuels are biogenic carbon. Coal, oil, and natural gas are the compressed remains of ancient organisms. When you burn them, you release carbon with a very specific isotopic fingerprint. A fingerprint that is, in fact, remarkably similar to what we see at the PETM boundary. Does this mean an industrial civilization caused the PETM? No. Frank and Schmidt said so explicitly. They strongly doubted it. The volcanic and methane hydrate explanations are far more parsimonious, far simpler, far more likely. But what they also said, carefully and precisely, is this. If such a civilization had existed and had burned through its fossil fuel reserves the way we are burning through ours, the chemical signature it left behind would look very much like what we see at the PETM. The two signals would be, in many cases, indistinguishable. And that is the part that keeps you awake. Not the claim that the PETM was caused by someone like us. Almost certainly it was not. But the realization that if it had been, we might never be able to tell. Because the Earth does not label its scars. It does not write the cause on the wound. It simply records the chemistry and moves on, leaving us to guess. The PETM is the deepest scar in recent geological memory, but it is not the only one. If you fast forward from 56 million years ago to a time much closer to our own, you find another event, another catastrophe, another moment where the world changed in ways that the standard explanations struggle to fully contain. And this time, the scar is not just chemical. This time, it comes with bodies, with the sudden silence of entire species, and with a trail of evidence that points not down into the earth, but up, into the sky. Picture the world, 12,800 years ago. The great ice sheets that had covered much of North America and Northern Europe for tens of thousands of years are finally retreating. The climate is warming, Spring is coming to a planet that has been locked in winter for an age. Mammoths still roam the tundra, their breath making clouds in the cold morning air. Saber-toothed cats prowl through forests that are spreading into land. The glaciers abandoned. Giant ground, sloths the size of cars graze peacefully in the woodlands of the Americas. The world is thawing. The future feels wide open. In North America, a culture of skilled hunters thrives. Scientists call them the Clovis people, named after a site near Clovis, New Mexico, where their distinctive stone spear points were first discovered. These tools are remarkable. Fluted, symmetrical, razor-sharp, beautiful in the way that only something perfectly designed for its purpose can be. They represent some of the finest stone tool technology in the prehistoric world. The Clovis people are not primitive. They are adapted, resourceful, and successful. They have spread across a continent, and then, in what appears to be the span of a single human lifetime, everything falls apart. The megafauna vanish, not slowly, not through a long, gradual decline over thousands of years. They disappear. In North America alone, 35 genera of large animals go extinct in a geological instant. Mammoths, mastodons, giant ground sloths, short-faced bears, American lions, saber-toothed cats, dire wolves, red giant beavers the size of black bears, American camels, American horses, gone, all of them, at roughly the same time. A 2008 study described the extinction as catastrophic, seemingly too sudden and too extensive for either human hunting or climate change alone to explain. The Clovis culture vanishes at the same moment. Their beautiful fluted tools disappear from the archaeological record as if someone drew a line in the dirt and said, everything on this side is over. Whatever culture came after was different, simpler, less refined, as if the knowledge and tradition that had produced those elegant weapons had been interrupted, broken, lost, and the climate itself flips. Temperatures that had been rising steadily for thousands of years suddenly plunge. The planet is thrown back into near glacial conditions with shocking speed. In parts of Greenland, annual average temperatures may have dropped by as much as 10 to 15 degrees Celsius within decades, possibly within years. The warm period that had been melting the ice and opening new lands for human life was slammed shut like a door. Winter came back with a vengeance and stayed for over 1,200 years. Scientists call this cold snap the Younger Dryas, named after a small Arctic wildflower called Dryas octopetala. Its pollen suddenly reappeared in European sediments that had previously recorded warmer-loving plants. The little flower's return was a quiet signal that something terrible had happened. The world was freezing again. The conventional explanation for the Younger Dryas has been taught in universities for decades. It goes like this. As the ice sheets melted, enormous volumes of fresh water accumulated in glacial lakes across North America. The largest of these was Lake Agassiz, a body of water so vast it would have dwarfed all 5 of today's Great Lakes combined. At some point, this lake burst. A wall of cold, fresh water poured into the North Atlantic Ocean in a catastrophic flood. The Atlantic Ocean has a circulation system sometimes called the Great Conveyor. Warm tropical water flows northward along the surface, keeping Europe and the North Atlantic relatively mild. Cold, salty water sinks in the north and flows back south along the ocean floor. It is a loop, a heat pump, and it depends on a delicate balance of temperature and salinity. If you suddenly dump an ocean of cold, fresh water into the North Atlantic, you break the pump. The warm water stops flowing north. Europe freezes. The effects ripple across the entire planet. This freshwater pulse hypothesis is solid science. It explains the sudden cooling. It explains the abrupt climate reversal. But it does not explain everything. It does not easily explain why 35 genera of large animals went extinct simultaneously across an entire continent. It does not explain the disappearance of the Clovis culture, and it does not explain what a growing number of researchers have found buried in the boundary layer between the warm period and the Younger Dryas. Things that should not be there. In 2007, a team of roughly 20 scientists led by Richard Firestone and Alan West presented findings that would change the conversation about the Younger Dryas forever. They had examined sediment layers from multiple sites across North America, all dating to approximately 12,900 years before present. And in those layers, they found an assemblage of materials that told a very different story from melting ice and bursting lakes. They found nanodiamonds, microscopic diamonds that only form under conditions of extreme heat and pressure, the kind of heat and pressure you find at nuclear test sites or at cosmic impact zones. They found magnetic microspherules, tiny metallic balls that form when rock or soil is melted and then resolidifies in midair. They found elevated levels of iridium, an element that is rare on Earth's surface but common in asteroids and comets. They found shocked quartz, grains of quartz with fracture patterns that are only produced by enormous pressure waves. And they found carbon spherules, soot, and widespread evidence of intense burning across vast areas. The team proposed something dramatic. A large, low-density extraterrestrial object, most likely a fragmented comet, had exploded over or struck the northern hemisphere approximately 12,900 years ago. The energy released would have been equivalent to thousands of nuclear weapons detonating at once. The shockwave and thermal pulse would have devastated everything beneath it. Fires would have swept across the landscape. A dust and soot thrown into the upper atmosphere would have blocked sunlight for months, triggering rapid cooling. And if the fragment struck or exploded above the massive Laurentide ice sheet covering North America, the resulting destabilization could have released enormous volumes of meltwater into the Atlantic, shutting down the ocean's circulation system. One event, one cause, and suddenly, everything that happened 12,800 years ago clicks together. The megafaunal extinction, the destruction of the Clovis culture, the evidence of continent-wide fires, the climate flip, the ocean circulation shutdown, all of it linked, all of it triggered by fire from the sky. The scientific community reacted with intensity. Critics pointed out that there was no obvious impact crater, but proponents had an answer for that too. A comet that fragments in the atmosphere, an airburst, does not necessarily leave a traditional crater. In 1908, a relatively small extraterrestrial object exploded in the atmosphere above Tunguska, Siberia. It flattened 2,000 square kilometers of forest. Trees were knocked down in a radial pattern extending for miles in every direction. The blast was estimated at roughly 15 megatons, 1,000 times more powerful than the Hiroshima bomb, and it left no crater at all. Scale that up by orders of magnitude, multiply the fragments, spread them across a continent, and you begin to see what the Younger Dryas impact might have looked like. The hypothesis was born in controversy, and it remains controversial today. The mainstream consensus still favors the freshwater pulse explanation, but the impact hypothesis has not gone away. In recent years, new evidence has emerged that has given it fresh strength. Evidence found in craters buried under ice, in sediment layers containing materials forged at temperatures exceeding 2,000 degrees, and in the silent testimony of a world that changed too fast for any slow, natural process to explain. That evidence, and the discoveries that have reshaped this debate in the last few years, is exactly where our path leads next. into the boundary layer itself, into the diamonds and the fire-forged glass, into the craters that were hiding in plain sight beneath thousands of feet of ice. The critics had a point. If a comet struck the Earth 12,800 years ago with the force of thousands of nuclear weapons, where was the crater? Every major impact event in Earth's history left a scar. The Chicxulub crater in Mexico, the one that ended the dinosaurs, is over 100 miles wide. You can see it from space. If something that powerful hit the planet at the dawn of human memory, there should be a hole in the ground, a big one. And for years, the absence of that hole was the strongest argument against the Younger Dryas impact hypothesis. Then, in 2018, researchers found the hole. Beneath the Hiawatha Glacier in northwestern Greenland, buried under 3,000 feet of ice, scientists discovered a massive impact structure. It is over 19 miles wide. 19 miles. A crater large enough to swallow a major city, hidden beneath an ice sheet that had kept it sealed and silent for thousands of years. The discovery was made using airborne ice-penetrating radar, technology that can see through glacial ice and map the bedrock beneath. The radar revealed a circular depression with a raised rim and central peaks, the classic signature of a large impact crater. Initial estimates placed the crater's age at roughly 12,800 years, squarely within the Younger Dryas window. The scientific world took notice. Here was the missing piece, the physical proof that a major cosmic impact had occurred at exactly the right time. Subsequent dating efforts have pushed the age back somewhat, and debate continues about whether the Hiawatha crater is directly connected to the Younger Dryas event. Some researchers now believe it may be older, perhaps formed during an earlier period. But its discovery proved something crucial. Large impacts during this general time frame are not fantasy. They are documented geological reality, and the Hiawatha crater was not the only discovery. In 2025, researchers published findings from an unlikely location, Louisiana. In the flatlands of the American South, they identified a crater-like depression nearly 1,000 feet long. Analysis of the site revealed that it was formed by what appears to have been a cosmic airburst dating to approximately 12,800 years ago. The materials found at the site read like a checklist from the original Younger Dryas impact hypothesis. Magnetic microspherules, shocked quartz, glass formed at temperatures exceeding 2,000 degrees Celsius. These are not the kinds of things produced by floods or volcanic eruptions or forest fires. These are the products of extraordinary violence, the kind of violence that comes from space. The researchers noted something chilling. The characteristics of the Louisiana site matched those found at nuclear test sites in New Mexico and Kazakhstan, locations where atomic detonations had created similar features in the soil. Whatever happened in Louisiana 12,800 years ago, it released energy comparable to a nuclear explosion. Not a bomb dropped by human hands. A bomb dropped by the universe, and the evidence was not limited to land. In deep ocean sediment cores pulled from Baffin Bay, the body of water between Greenland and Canada, researchers found silica and iron-rich microspherules at the same stratigraphic level. The same moment in time recorded in marine sediment far from any land-based site. The oceanic evidence complemented the terrestrial findings. Whatever happened, it was not local. It was not a single explosion in a single place. It was widespread, continental in scale, perhaps hemispheric. The picture that emerged from these discoveries was becoming harder and harder to dismiss. Go back to that original 2007 paper by Firestone, West, and their colleagues. They had documented nanodiamonds at multiple sites across North America. Nanodiamonds are not ordinary diamonds. You cannot put them in a ring. They are microscopic, invisible to the naked eye, and they form only under conditions of extreme pressure and temperature, the kind of conditions found inside a nuclear fireball, or at the point where a cosmic object traveling at tens of thousands of miles per hour meets the Earth's atmosphere or surface. Critics initially challenged the nanodiamond findings, questioning the identification methods and suggesting the diamonds could have formed through natural processes like forest fires or lightning strikes. But subsequent studies, using refined techniques and expanded sample sets, confirmed the presence of nanodiamonds at the Younger Dryas boundary layer. Not at one site, not at a handful, at over 50 locations spread across North America, Europe, and parts of the Middle East and South America. 50 locations, all showing the same markers, all at the same stratigraphic level, all dating to the same narrow window of time. The magnetic microspherules tell a similar story. These tiny metallic balls, smaller than grains of sand, form when rock or metal is heated to its melting point and then cools rapidly in the air. They are perfectly spherical because surface tension shapes the molten droplet before it solidifies. You find them at known impact sites, you find them at nuclear test sites, and you find them in abundance at the Younger Dryas boundary layer across multiple continents. The soot and carbon evidence adds another dimension. At the boundary layer, researchers documented a massive spike in charcoal and soot particles, evidence of continent-wide burning. The fires were not localized. They were not the kind of seasonal burns that occur naturally in grasslands and forests. They were enormous, simultaneous, and they left a carbon signature in the sediment that matches the scale of a catastrophic ignition event. Something set a significant portion of North America on fire at roughly the same moment. One team of researchers wrote that the only reasonable conclusion was that a major cosmic impact event occurred at this time and that its timing was so close to the onset of Younger Dryas cooling that a causal link was highly likely. Not certain. Science rarely deals in certainties, but highly likely. The mainstream scientific community remains divided, and many researchers still favor the freshwater pulse hypothesis as the primary trigger for the Younger Dryas cooling. The impact hypothesis is not the consensus view, but it has grown from a fringe idea into a serious scientific debate with evidence accumulating on both sides. And each new discovery, each new crater, each new site with nanodiamonds and microspherules and shocked quartz adds weight to the possibility that something came from the sky and changed the world. But here is where the story becomes something larger than a debate about comets and climate. Because if a cosmic catastrophe did strike the Earth 12,800 years ago, the question that follows is not just about geology. It is about us. It is about what was lost. What was the state of human civilization at that moment? What were people capable of? What had they built? What did they know? The standard archaeological answer is straightforward. Humans at this time were hunter-gatherers. Small bands of nomadic people following animal herds across open landscapes. No cities, no agriculture, no writing, no permanent structures. Simple people living simple lives in a simple world. But that answer has been under pressure for years, because in southeastern Turkey, on a dusty hilltop overlooking a landscape of rolling brown hills, something was found that the standard answer cannot explain. A complex of massive stone structures, intricately carved, precisely arranged, built by people who, according to every textbook, should not have been able to build anything at all. A site so old that it predates agriculture by thousands of years. A site that reversed the accepted sequence of human civilization and forced archaeologists to reconsider everything they thought they knew about what our ancestors were capable of before the world they knew was shattered. The temple came before the farm. the monument came before the village, and the oldest portions of this impossible structure date to the exact moment when the Younger Dryas cold period ended and the world began to warm again. As if someone, emerging from 1200 years of darkness and cold, immediately began building something monumental, not from scratch, but from memory, from knowledge that they carried through the catastrophe like a flame cupped in trembling hands. That site has a name, and it changes everything. Southeastern Turkey, the Germush Mountains, a landscape of dry rolling hills baked under a wide sky. 15 kilometers northeast of the ancient city of Şanlıurfa, a hill rises gently from the surrounding terrain. It does not look natural. It is a tell, an artificial mound created by thousands of years of human activity layered upon itself. The locals call it Göbekli Tepe, Potbelly Hill. For centuries, farmers worked the soil around it, occasionally turning up worked stones and fragments of carved rock. They stacked the stones along the edges of their fields and thought nothing of it. In 1963, a joint survey team from Istanbul University and the University of Chicago visited the site. They noted the worked stones. They recorded it as a medieval cemetery. They moved on. For 31 years, one of the most important archaeological discoveries in human history sat in plain sight, dismissed and ignored. Then, in 1994, a German archaeologist named Klaus Schmidt arrived. He had been working at another ancient site in the region and was searching for more locations of similar age. When local people directed him to the hilltop, he recognized the stone fragments immediately. These were not medieval. They were prehistoric, and they were very, very old. He began excavating in 1995. What emerged from the earth was so extraordinary that it took the archaeological world years to fully absorb what had been found. Massive T-shaped limestone pillars, some standing nearly 16 feet tall, some weighing as much as 20 tons, arranged in circles and embedded in walls of smaller stones. The pillars were covered with intricate carvings: foxes, lions, boars, snakes, vultures, scorpions, abstract symbols that no one has fully decoded. And on some pillars, arms carved in relief running down the sides with hands clasped at the front, as if the pillars were not just columns. They were stylized human figures, giant stone people standing in circles, facing each other in the dark. The circles are enormous. The largest measures roughly 66 feet across. Each enclosure contains 2 central pillars that are taller and more elaborately carved than those in the surrounding ring. 20 such enclosures have been identified so far, though surveys suggest many more remain buried. Only a fraction of the site has been excavated. What lies beneath the rest is still unknown. And then came the dates. Radiocarbon analysis placed the oldest structures at Göbekli Tepe at approximately 9,500 BCE, that is 11,500 years ago, more than 6,000 years before Stonehenge, more than 6,000 years before the Egyptian pyramids, older than any permanent human structure known to exist anywhere on this planet. Let that settle. 11,500 years ago, before agriculture, before pottery, before metalwork, before the wheel, before writing, before every single element of what we traditionally define as civilization. The people who built Göbekli Tepe were, according to every other line of evidence we possess, hunter-gatherers. They had no domesticated plants, no domesticated animals, no permanent villages, no written language. And yet, they built this. They quarried limestone blocks weighing up to 20 tons from outcrops hundreds of yards away. They shaped these blocks into precise T-forms using nothing but flint tools. They carved elaborate animal reliefs into hard stone, work that required not just physical skill, but artistic sophistication and symbolic thinking of the highest order. They transported these massive pillars to the hilltop, erected them in carefully planned circular arrangements, and oriented them with a precision that implies mathematical understanding. Research published in the Cambridge Archaeological Journal revealed that the builders used geometric principles to plan the layout. The three main enclosures are connected by an equilateral triangle, suggesting the entire complex was conceived as a single unified design, rather than a random collection of structures added over time. The builders stretched ropes to measure distances. They established angles. They worked with a degree of planning and coordination that implies organizational ability far beyond what anyone had previously attributed to hunter-gatherer societies. And then, after centuries of use, something strange happened. Around 8000 BCE, the people who had built and used these structures deliberately buried them. They did not abandon the site and let nature reclaim it. They actively filled the enclosures with earth, rubble, and refuse. They sealed it, as if they were protecting it, or hiding it, or closing a chapter that they knew would not be reopened. Nobody knows why. Theories range from ritual closure to practical concealment, but the burial is what preserved Göbekli Tepe so remarkably well. Without it, 12,000 years of erosion and earthquakes would have reduced the site to scattered rubble. The burial, whether intentional or not, was an act of preservation across millennia. Before Göbekli Tepe, the accepted sequence of human development was clean and simple. Agriculture came first. Farming created food surpluses. Surpluses allowed permanent settlements. Settlements created specialization. Specialization created social hierarchies. Hierarchies created organized religion. Religion created the desire to build temples and monuments. Farm first, then build. That was the rule. Göbekli Tepe broke the rule. The temple came first. Long before anyone in the region had domesticated a single grain of wheat, people were gathering on this hilltop to carve and raise massive stone monuments. Klaus Schmidt proposed that the construction itself may have driven the invention of agriculture. Building Göbekli Tepe required such a large labor force gathering for extended periods that the need to feed those workers pushed people toward deliberate cultivation of wild grains. The temple created the need for the farm, not the other way around. And there is evidence for this. Just 20 miles from Göbekli Tepe, geneticists found the world's oldest domesticated strains of wheat. Radiocarbon dating places this domestication at roughly 10,500 years ago, just 500 years after construction at Göbekli Tepe began. The cradle of agriculture and the world's oldest temple are neighbors. The timing is not coincidental. It is causal. But there is another interpretation, one that whispers rather than shouts. What if Göbekli Tepe is not the beginning of something? What if it is the end? What if the knowledge, the organizational skill, the architectural vision, the symbolic language carved into those pillars did not spring fully formed from the minds of nomadic hunters? What if it was inherited, passed down from a previous tradition, a previous culture, a previous level of achievement that was disrupted or destroyed by the catastrophe at the end of the Ice Age? The timing is impossible to ignore. 2. The Younger Dryas ended approximately 11,600 years ago. The oldest structures at Göbekli Tepe date to approximately 11,500 years ago. The gap is negligible. As if the moment the cold released its grip, someone began building immediately, urgently, with a level of skill that implies they did not invent it on the spot. They already had it. On one of the most famous pillars, Pillar 43, also called the Vulture Stone, a complex scene is carved. A vulture holds a round object. Below it, a scorpion, Around them, other animals and abstract symbols. Researchers from the University of Edinburgh have proposed that these carvings encode astronomical information, that the animals represent constellations, that the scene depicts a specific date written in the language of the stars. The date they propose is approximately 10,950 BCE, right at the onset of the Younger Dryas. If this interpretation is correct, Göbekli Tepe is not just a temple. It is a memorial, a record carved in stone to mark a catastrophe, a message left by survivors saying we remember what happened. We remember the fire from the sky. Whether or not you accept that reading, one fact remains beyond dispute. 12,000 years ago, human beings were capable of far more than the textbooks allowed. And if they could build this on a hilltop that survived because it stood above the rising seas, what might they have built along coastlines that now lie beneath 300 feet of water? Coastlines we have never explored, like landscapes we have never examined, entire worlds swallowed by the ocean and forgotten. Göbekli Tepe survived because of its elevation. Whatever stood at sea level did not. And another ancient monument, far to the south, carries its own impossible secret. Written not in carvings but in the pattern of rain on stone. Egypt, the Giza Plateau. The most famous monument on Earth crouches in the sand, facing due east, staring at the rising sun with an expression that has not changed in thousands of years. A limestone body the size of a building, a human head on a lion's frame. Not built block by block like the pyramids beside it, but carved downward from the living bedrock, cut from the surface of the plateau itself, liberated from the rock that once surrounded it like a sculpture freed from a block of marble. The Great Sphinx. You have seen it 1,000 times in photographs. But photographs do not prepare you for the feeling of standing beside it. The sheer mass, the silence, the weight of time pressing down on every surface, and the question that has followed this monument like a shadow for the last 3 decades. How old is it really? According to mainstream Egyptology, the Sphinx was carved around 2500 BCE during the reign of the pharaoh Khafra, builder of the second largest pyramid at Giza. The evidence for this dating is largely circumstantial. There is no inscription on the Sphinx that names its builder. There is no contemporary record of its construction. The attribution to Khafra rests on proximity to his pyramid, stylistic similarity to Old Kingdom art, and a damaged stela between the Sphinx's paws that may reference Khafra's name, though the relevant portion of the text is eroded and impossible to read with certainty. For most of the 20th century, nobody seriously questioned this date. Khafra built the Sphinx around 2500 BCE. Case closed. Textbook settled. Move along. Then, in 1990, a geologist walked into the Sphinx enclosure and saw something that should not have been there. His name was Robert Schoch. He held a PhD in geology and geophysics from Yale University. He was an associate professor at Boston University. He was not an Egyptologist. He was not a mystic or a treasure hunter. He was not looking for lost civilizations. He had been invited to Egypt by John Anthony West, an independent researcher who had long suspected the Sphinx was older than its official date. West wanted a trained geologist to examine the rock. Schoch went expecting to confirm the conventional timeline. It took him seconds to see the problem. The walls of the Sphinx enclosure, the trench carved into the bedrock when the Sphinx's body was freed from the surrounding limestone, showed deep, rounded, vertical grooves. Undulating surfaces, fissures that were wider at the top than at the bottom. To a trained geologist, these patterns were unmistakable. They were the product of water erosion, specifically rainfall erosion. Water running down vertical surfaces over extended periods, dissolving the limestone from above, carving the characteristic rounded channels that rain leaves on soft rock. The problem is that the Sphinx sits on the edge of the Sahara Desert. The Giza Plateau has been essentially dry for the last 5,000 years. Rainfall in the region is minimal. The dominant weathering force on the plateau is wind and wind-blown sand, which produces a completely different erosion pattern. Wind erosion creates horizontal striations, sharp edges, angular profiles. The surfaces on the Sphinx enclosure walls did not look like wind damage. They looked like centuries of heavy rain. Schoch examined other structures on the Giza Plateau that were securely dated to the Old Kingdom, Khafra's era. Rock-cut tombs carved from the same geological formations showed erosion consistent with wind and sand, sharp horizontal layers, angular surfaces, desert weathering. The Sphinx and its enclosure showed something entirely different. Deep vertical grooves, rounded surfaces, water damage. If both structures were carved at the same time, from the same rock, under the same climate, they should show the same erosion patterns. They do not. The simplest explanation, Schoch argued, was that they were not carved at the same time. The Sphinx was older, much older, old enough to have stood under a sky that poured rain. When did Egypt last experience sustained heavy rainfall? During the African humid period, roughly 12,000 to 5,000 years before the Common Era. The Sahara was not a desert during this time. It was green savanna. Lakes dotted the landscape. Rivers flowed where there is now only sand. Rock art found deep in what is now barren desert shows people swimming, herding cattle, and living beside waterways that vanished thousands of years ago. Schoch initially estimated the Sphinx's construction at before 5000 BCE. Later, as his research continued, he pushed further back, suggesting the core body may date to approximately 10,000 BCE or earlier. That would make the Sphinx not 4,500 years old, but 12,000 years old, possibly more. The response from mainstream Egyptology was fierce. Mark Lehner, one of the world's leading authorities on the Giza Plateau, rejected the hypothesis. You do not overthrow Egyptian history based on one phenomenon like a weathering profile, he said. Other critics proposed alternative explanations, salt weathering, moisture absorbed from sand that periodically buried the Sphinx, rainwater seeping through porous soil over long periods. Geologist James Harrell of the University of Toledo argued that subsurface moisture could produce similar patterns without requiring a wetter climate. These counter-arguments carry weight. The geology of Giza is complex. Multiple weathering processes operate simultaneously. But Schoch pushed back with additional evidence. He conducted seismic surveys around the base of the Sphinx, using sledgehammers on steel plates to generate sound waves that penetrated the bedrock. The reflected signals revealed the depth of subsurface weathering, how far down into the rock the erosion extended. The data showed extraordinary depth, deeper than what would be expected for a monument only 4,500 years old, consistent with prolonged, uniform weathering from above. Rainfall, not localized flooding, not moisture from sand. Rainfall. There is another detail that is difficult to dismiss. The head of the Sphinx is too small for the body, and precise measurements confirm this. The proportions are wrong. The head is disproportionately small relative to the massive frame beneath it, and the tool marks on the head are relatively recent, consistent with Old Kingdom craftsmanship. This led Schoch and others to propose that the head was recarved, that the original head, whatever it depicted, had been so badly damaged by thousands of years of weathering that a later pharaoh reshaped it into its current form. A smaller head carved from a larger, eroded original would explain both the odd proportions and the different tool marks. If the body is ancient and the head was recarved during the Old Kingdom, the discrepancy in erosion patterns makes perfect sense. The body endured thousands of years of rainfall. The head was freshly carved around 2500 BCE and has experienced only desert conditions since. There is one more piece to consider. The Sphinx faces due east. On the morning of the spring equinox, it gazes directly at the rising sun. But because of precession, the slow wobble of Earth's axis over a roughly 26,000-year cycle, the constellation visible on the eastern horizon at equinox sunrise changes over time. 4,000 years ago, when Egyptologists say the Sphinx was carved, the rising constellation was Taurus, the bull. But if you rewind the sky to approximately 10,500 BCE, the constellation rising at the spring equinox was Leo, the lion. A lion monument facing east, staring at the constellation of the lion at sunrise on the equinox. The alignment is precise. The symbolism is unmistakable. And the date falls squarely within the window Schoch proposed. Coincidence? Perhaps. But it is a coincidence that has fueled 3 decades of argument. The Sphinx debate remains unresolved. Mainstream archaeology holds firmly to Khafra. The geological evidence raises questions that have not been fully answered, and the implications, if Schoch is right, are enormous. Someone was in Egypt at the end of the Ice Age with the knowledge and motivation to carve a monument from bedrock on a scale that would not be matched for thousands of years. And halfway across the world, another impossible artifact was waiting. Not carved in stone, but drawn on the dried skin of a gazelle. A map made in 1513 that appears to show something no one in the 16th century should have known existed. In 1929, in the basement of the Topkapi Palace in Istanbul, a German theologian named Gustav Adolf Deissmann was sorting through old documents at the request of the Turkish government. The palace had been the heart of the Ottoman Empire for centuries. Its archives held thousands of uncatalogued items crammed into storage and largely forgotten. Dusty scrolls, faded manuscripts, administrative records from a vanished empire, and rolled up on a shelf, a piece of dried animal skin that would become one of the most debated artifacts in the history of cartography. Deissmann unrolled it carefully. It was gazelle hide, brittle with age. On its surface was a map, a fragment, clearly about 1/3 of what had once been a much larger chart. But even as a fragment, it was extraordinary. The map had been drawn and signed in 1513 by an Ottoman admiral and cartographer named Hagji Ahmed Muhiddin Piri, known to history as Piri Reis. He was a seasoned sailor and a devoted collector of geographical knowledge. In his own annotations on the map, written in Ottoman Turkish, Piri Reis explained that he had compiled his chart from approximately 20 different source maps. 8 were Ptolemaic maps based on the geographical knowledge of the ancient Greeks. 4 were Portuguese charts from recent explorations. 1 was an Arabic map, and 1, Piri Reis claimed, was drawn by Christopher Columbus himself, a map that has since been lost to history. The Piri Reis fragment is the only surviving copy of any part of Columbus's original chart. The map itself is a Portolan chart, a type of nautical navigation map featuring compass roses and a network of rum lines. It depicts the western coast of Africa, the Iberian Peninsula, and the eastern coast of South America with remarkable detail for its era. The coastline of Brazil is rendered with accuracy that impressed modern cartographers when the map was first studied. But the feature that launched the Piri Reis map into mystery and controversy sits at the bottom of the fragment. Below the South American coastline, The map depicts a large continuous landmass extending southward and curving to the east. A landmass that, to some eyes, looks very much like the northern coast of Antarctica. The problem is immediate and obvious. Antarctica was not officially discovered until 1820, more than 300 years after Piri Reis drew his map. No European, no Ottoman, no known explorer had reached Antarctica in 1513. If that southern landmass is Antarctica, how did Piri Reis know it was there? The mystery deepened in 1965 when Professor Charles Hapgood of the University of New Hampshire published a book called Maps of the Ancient Sea Kings. Hapgood and his students had studied the Piri Reis map in detail and found several anomalies. The map appeared to use a form of Mercator projection, a method of representing the curved Earth on a flat surface that European cartographers did not widely adopt until later in the 16th century. Certain geographical features seemed more accurate than the navigational technology of 1513 should have allowed. But Hapgood's most startling claim was about the southern landmass. He argued that it did not merely depict Antarctica. It depicted Antarctica without its ice cap. The coastline shown on the map, he claimed, corresponded not to the ice-covered coast visible today, but to the actual rock coastline buried beneath thousands of feet of glacial ice. A coastline that was only mapped by modern technology, seismic surveys and satellite imaging, in the 20th century. If Hapgood was right, someone at some point in the deep past had mapped Antarctica before it was covered by ice. That someone possessed the navigational skills to reach the continent, the cartographic skills to map it accurately, and the means to transmit that knowledge forward through time, until it eventually reached Piri Reis through a chain of source maps stretching back into antiquity. Hapgood did not invoke aliens. He proposed a lost human civilization capable of oceanic navigation and accurate cartography thousands of years before the Greeks. His earlier work had been reviewed favorably by Albert Einstein, who wrote a foreword to one of Hapgood's books, though Einstein did not specifically endorse the ancient Sea Kings theory. Graham Hancock later cited the Piri Reis map as key evidence in his best-selling book, Fingerprints of the Gods. The map became a cornerstone of the lost civilization narrative. But the story is more complicated than the mystery enthusiasts suggest. Critics have raised serious and well-supported objections. First, the identification of the southern landmass as Antarctica is far from certain. Many cartographic historians argue that it is actually a distorted depiction of the southern coast of South America. In the early 16th century, the full extent of South America's southern coastline was unknown. Mapmakers routinely extended coastlines based on speculation or inherited classical Greek theory that a large southern landmass must exist to balance the northern continents. This hypothetical terra australis appeared on many maps of the era long before anyone had seen Antarctica. Piri Reis may simply have been following this convention. Second, Hapgood's claim that the map shows an ice-free Antarctica has been challenged by subsequent research. A 1949 survey that Hapgood relied upon covered less than 1% of the area depicted on the map. Later studies with access to far more data found no significant similarity between the coastline on the Piri Reis map and the actual subglacial coastline of Antarctica. Modern ice core data also shows that Antarctica has been covered by ice for at least 10 million years. Hapgood's belief that the continent was ice-free as recently as 4000 BCE was simply wrong. Third, the annotations on the map itself undercut the Antarctic interpretation. Near the southern landmass, Piri Reis wrote that the land is uninhabited, that everything is in ruin, and that the region is said to be very hot and home to large snakes. This description does not fit Antarctica by any measure. It fits the tropical coast of South America far more naturally. So is the Piri Reis map evidence of a lost civilization with advanced cartographic knowledge? The scholarly consensus says almost certainly not. The map is a remarkable but ultimately explainable product of early 16th century cartography, compiled from a mix of contemporary and older sources, containing the typical errors and speculations of its era. And yet, the Piri Reis map is not the only anomalous map from this period. The Orontius Phineas map of 1531 also depicts a southern landmass, with features some have compared to Antarctica. The Boacha map of 1739 shows what appears to be a southern continent divided by waterways that some have compared to the subglacial topography of Antarctica. Mainstream cartography explains each of these as variations on the Terra Australis tradition, speculative depictions based on theory rather than observation. But the recurring pattern raises a quiet question. Why do so many early maps include a southern landmass? Why do some show features that even by coincidence resemble the actual geography of a continent not discovered for centuries? Is it all inherited Greek philosophical speculation? Or is there, buried somewhere in the chain of source maps that Piri Reis and others drew upon, a fragment of knowledge that is older and stranger than anyone is comfortable admitting? The honest answer is that we do not know. The maps alone cannot prove the existence of a lost civilization. But they fit the larger pattern we have been tracing. Another piece that does not quite slot into the conventional puzzle. Another whisper in a growing chorus of whispers. And not far from where Piri Reis once sailed, in the volcanic heartland of modern Turkey, another impossible achievement waits beneath the surface. Not drawn on animal skin, not carved on a hilltop, carved downward, into the earth itself. 18 stories deep, engineered to shelter 20,000 people from something on the surface so terrible that the only safe place was underground. In 1963, a man in the Turkish town of Derinkuyu was renovating his house. He picked up a sledgehammer and swung it into a basement wall. The stone crumbled. Behind it, darkness. Not the shallow darkness of a crawl space or a forgotten cellar. Something deeper. A passageway leading down into the rock. He pushed through the debris and found a tunnel. The tunnel led to a room. The room led to another tunnel. That tunnel led to another room. And another. And another. Each one deeper than the last. Each one carved from the soft volcanic stone of the Cappadocia region with a precision that spoke of purpose, of planning, of fear. What this unnamed homeowner had broken into was one of the most extraordinary archaeological discoveries of the 20th century. An entire underground city extending approximately 85 meters, roughly 280 feet, straight down into the earth. 18 levels deep. Not a cave, not a mine, a city. With ventilation shafts, water wells, storage rooms, stables, wine presses, oil presses, kitchens, meeting halls, schools, and chapels. A place designed not just for hiding, but for living. For surviving underground for weeks, possibly months. Massive circular stone doors, each weighing several hundred pounds, could be rolled across corridor entrances from the inside, sealing each level against intruders. The doors could not be opened from outside. The corridors were deliberately narrow, tight enough that invaders would be forced to move single file, where defenders could stop them cold. Every floor could be sealed independently. If the upper levels were breached, the population could retreat deeper, closing stone doors behind them like airlocks on a submarine. The ventilation system was remarkable. A network of shafts ran from the deepest levels to the surface, providing fresh air throughout the complex. Some of these shafts doubled as wells, reaching down to the water table and supplying drinking water to the inhabitants below. The air circulation was so well designed that even at the lowest levels, the atmosphere remained breathable. This was not improvised. This was engineered by people who understood airflow, water tables, and structural loads. Derinkuyu could shelter up to 20,000 people along with their livestock and food supplies for extended periods. 20,000. That is not a hiding spot. That is an underground civilization, and Derinkuyu is not alone. The Cappadocia region contains over 200 known underground settlements. Some are small, just 2 or 3 levels. Others rival Derinkuyu in scale. Kaimakli, another vast underground city, lies just 5 miles away. Some researchers believe the two cities were once connected by a tunnel stretching nearly 9 kilometers between them, creating an underground network linking separate populations beneath the surface. In 2015, during construction of a housing project near the town of Nevşehir, yet another underground city was discovered beneath a hilltop castle. Initial surveys suggested it could be even larger than Derinkuyu, as extending over 100 meters deep and covering nearly 5 million square feet. And less than half of Derinkuyu itself has been excavated. Entire sections remain sealed off. What lies in the unexplored depths is still unknown. The conventional explanation for these underground cities is straightforward and well supported. Cappadocia sits at a crossroads of ancient empires. Hittites, Persians, Greeks, Romans, Byzantines, Arabs, Mongols, and Ottomans all fought for control of the region over thousands of years. The underground cities served as refuges during invasions. When armies appeared on the horizon, the local population descended into the rock, sealed the doors, and waited until danger passed. Historical records confirm this use during the Byzantine-Arab Wars, during Mongol raids, and even into the 20th century when Cappadocian Greeks and Armenians used the tunnels to escape persecution. The earliest construction is generally attributed to the Phrygians, who inhabited the region in the 8th and 7th centuries BCE. The soft volcanic tuff was easy to carve with simple tools. Later cultures, particularly Byzantine Christians, expanded the complexes dramatically, adding chapels, deeper levels, and the sophisticated defensive features we see today. This explanation is rational. It answers the questions of who and why with reasonable confidence. But it does not answer all the questions. The first unanswered question is scale. Carving a city for 20,000 people 18 stories into solid rock, even soft rock, is an extraordinary achievement. Someone had to design the ventilation system before the first shaft was dug. Someone had to calculate structural loads to prevent collapse. Someone had to map the water table to know where to place wells. Someone had to coordinate hundreds or thousands of workers over decades of continuous excavation. This is not the work of frightened villagers digging a hole. This is the work of engineers. The second question is depth. You do not need to go 18 stories underground to hide from a cavalry raid. A few levels would be more than enough. The extreme depth of Derinkuyu suggests that whoever designed the deepest portions was preparing for something more than a passing army. They were preparing for a scenario where the surface itself was uninhabitable for an extended period. Some alternative researchers have connected the underground cities of Cappadocia to the Younger Dryas event. Göbekli Tepe lies roughly 600 kilometers to the east. Both regions were inhabited during the same era. If a cosmic catastrophe struck the northern hemisphere 12,800 years ago, filling the sky with dust and debris, triggering fires and extreme cold, then going underground would be a logical survival strategy. Not hiding from human enemies, hiding from the sky itself. This theory is speculative. There is no direct archaeological evidence linking Derinkuyu's deepest levels to the Younger Dryas or to any cosmic event. The conventional dating places construction thousands of years later, but the theory persists because it addresses the question that conventional explanations leave hanging. Why dig so deep unless you had reason to fear the surface itself? There is another possibility worth considering. Cappadocia is volcanically active. The soft tuff that made the underground cities possible was itself produced by ancient eruptions. The people of this region would have known volcanic danger intimately. Ash falls, pyroclastic flows, toxic gases. Going underground during a volcanic event is rational, and digging deep enough to outlast a sustained eruption that could blanket the surface in ash for months might explain the extreme depth of these complexes. Whatever the original motivation, the underground cities represent something remarkable. Not just individual survival, not a family hiding in a cave, an entire community organized, provisioned, and engineered to survive beneath the surface for extended periods. They represent a civilizational response to existential threat, a collective understanding that sometimes the surface is not safe, that sometimes the only way to survive is to go down. And that understanding, that deep ancient knowledge that the world above can become hostile and deadly, echoes through the oldest stories humanity has ever told. Stories told on every inhabited continent. Stories told by peoples separated by oceans who supposedly never spoke to each other. Stories about a time when the surface was not merely dangerous, but destroyed. When the water came and covered everything. When the world ended and began again. Not one flood story, yet not a handful, hundreds of them, thousands, told by the Sumerians and the Hebrews, the Greeks and the Hindus, the Chinese and the Norse, the Aboriginal Australians and the Hopi, the Aztecs and the Inca, all telling essentially the same tale. The gods were angry, the sky fell, the waters rose, a few survived, and civilization had to start over from the beginning. If these stories are just myths, why do they all say the same thing? And why do the details, when you strip away the gods and the magic, match what we know happened at the end of the Ice Age? The oldest story humanity has ever written down is about the end of the world. Not a future apocalypse, a past one. A time when the water came and swallowed everything. A time when the gods looked down at what they had made and decided to start over. A time when, out of the wreckage, a handful of survivors rebuilt and began again. The most familiar version in the Western world is the story of Noah. God saw wickedness in humanity. He warned one righteous man. Noah built an ark, loaded it with his family and pairs of every animal, and survived the deluge. The waters receded. A dove returned with an olive branch. The world began again. This story has been told for roughly 3,000 years, but it is not the oldest version. The oldest written flood story comes from ancient Sumer, the civilization that arose in southern Mesopotamia roughly 5,000 years ago. In the Sumerian king list, one of the earliest historical records ever compiled, the kings of the world before the flood are listed with impossibly long reigns. Then comes a single line. The flood swept over. Kingship descended again from heaven, and a new line of kings begins. In the Epic of Gilgamesh, the greatest surviving work of ancient literature, the hero Gilgamesh travels to the end of the world to find Utnapishtim, the only man ever granted immortality. Utnapishtim tells how the gods decided to destroy humanity. But one god, Ea, warned him in secret, speaking through the wall of his reed house. Tear down your house, build a boat, load it with the seed of all living things. Utnapishtim built the boat. The storm raged for 6 days and 7 nights. the waters rose until even the gods were terrified. When the storm passed, the boat came to rest on a mountain. Utnapishtim sent out a dove. It returned. He sent a swallow. It returned. He sent a raven. It did not return. The waters were receding. The parallels to Noah are unmistakable. A divine warning, a great vessel, a catastrophic flood, animals preserved, a mountain landing, birds sent to find dry land. Scholars have long recognized that the Genesis account was influenced by the older Mesopotamian tradition. The earlier epic of Atrahasis, dating to the 18th century BCE, tells a similar story. The Sumerian Eridu Genesis provides yet another version. The flood was central to Mesopotamian culture long before it entered the Hebrew Bible. But here is what makes this so much larger than one region's mythology. The Mesopotamian flood stories are not unique. They are not unusual. They are one expression of a narrative found in virtually every culture on every inhabited continent. In Hindu tradition, the god Vishnu warns the sage Manu of an approaching flood. Manu builds a boat, loads it with seeds and animals, and survives. In Greek mythology, Zeus destroys humanity with a flood, and only Deucalion and Pyrrha survive in a floating chest, landing on a mountaintop to repopulate the earth. In Chinese mythology, a great flood is a foundational event in civilizational memory. Among the Norse, the world begins with a primordial flood. Among the Aboriginal Australians, flood stories are among the oldest continuously maintained oral traditions on Earth, some potentially preserving memories of real coastal changes dating back 10,000 years or more. In the Americas, flood myths are everywhere. The Hopi tell of a world destroyed by water because the people had become corrupt. The Aztecs describe a fourth age of the world that ended in catastrophic flooding. The Maya Popol Vuh describes the destruction of an earlier creation by a great deluge. South American traditions from the Andes to the Amazon contain similar accounts. Scholars have catalogued over 500 distinct flood myths from cultures around the world. Many of these cultures had no known contact with each other. They spoke different languages, lived in different environments, practiced different religions, used different technologies, yet they all tell essentially the same story. The world was destroyed by water. A few survived. Civilization started over. The conventional explanation is cultural convergence. Floods are a universal human experience. Nearly every settlement in history was built near water because water is essential for survival. And water floods. Every culture near water has experienced catastrophic flooding at some point. These local disasters become mythologized over generations, growing in scale until they become creation narratives about the end and beginning of the world. This explanation has real merit, but it does not account for the specificity of the parallels. Many flood myths share structural details that go beyond generic catastrophe, a divine warning, a chosen survivor, a vessel for preservation, animals saved, a mountain landing, birds sent to scout, a sacrifice of gratitude, a new beginning. These details recur across cultures that had no apparent way of sharing stories. Independent invention is possible. Humans are pattern makers, but the degree of convergence is striking, and it invites an alternative explanation. What if the flood myths are not independent inventions? What if they are memories? Not memories of a single simultaneous global flood. The physics do not support that. There has never been enough water on Earth to cover all land at once, but memories of a process, a prolonged, a devastating process that affected coastlines and river valleys around the world over thousands of years. At the end of the last ice age, beginning roughly 15,000 years ago and continuing until approximately 7,000 years ago, global sea levels rose by over 120 meters, nearly 400 feet. Coastlines that had been stable for tens of thousands of years were drowned. Entire landmasses disappeared. The Bering Land Bridge between Asia and North America. The connection between Britain and Europe. The vast Sundaland Shelf between Southeast Asia and Indonesia. Continental shelves of India, Australia, and the Americas. All submerged. The process was not always gradual. Meltwater pulses, sudden releases of enormous volumes of water from collapsing ice sheets, could raise sea levels by several meters within decades. For coastal populations, this would have been catastrophic. Settlements drowned, fishing grounds destroyed, communities displaced, and if a meltwater pulse coincided with a storm surge or tsunami, the destruction would have been apocalyptic. Imagine a community living on a coastal plain 12,000 years ago. They have lived there for generations. The sea provides everything. Then, the water begins to rise. At first, slowly. The beach creeps closer. Camps are moved inland, then faster. A storm comes and the sea does not retreat. Fields flood. Wells turn salty. Within a lifetime, the land their grandparents walked is underwater. Within a few more generations, there is no memory of it, except a story. A story about the time the water came and took everything. Now multiply that by every coast on every continent. Repeat it over 8,000 years. Layer upon layer of loss. Generation after generation, watching the ocean swallow their world. Is it any wonder that every culture remembers a flood? And here is the question that matters most for our journey tonight. If a civilization existed during the Ice Age, a people who built and traded and navigated along coastlines that are now deep underwater, where would the evidence be? Not on the highlands, not in the mountains. Civilizations cluster along coasts and rivers. Their remains would be on the continental shelves, the very lands now submerged beneath 120 meters of ocean. We have not looked there. Marine archaeology is expensive, difficult, and limited in scope. Thousands of square miles of terrain that was once dry, habitable, coastal land sits beneath the waves, unexamined. If proof of a lost civilization exists anywhere, it is there, under the water, under the sediment, under 12,000 years of silence. The flood myths may not be about divine punishment at all. They may be about real water, real loss, real memory, passed down across millennia in the only format that pre-literate people had: story, myth, legend. And perhaps those stories are trying to tell us something we have not yet been willing to hear. So here we are, at the end of the journey, or perhaps at the beginning of one. We have traveled from the laboratories of NASA scientists to the geological record of 56 million years ago. We have followed the trail of a comet through skies that burned 12,800 years before anyone alive today drew breath. We have stood inside a temple that predates agriculture by thousands of years. We have traced the grooves of rain on a monument in a desert that has not seen rain in millennia. We have unfolded a map that shows a coastline 3 centuries before its discovery. We have descended 18 stories beneath the surface of the earth into cities carved for survival. And we have listened to the oldest stories humanity has ever told, now whispered across generations like a flame passed from hand to trembling hand. Now comes the question we have been circling all night. The question that sits at the center of everything, like a stone at the bottom of a well. What if we are not the first? Let us be honest about what we know. We know the Earth is 4.5 billion years old. We know complex life has existed for over 500 million years. We know intelligent, social, tool-using animals have walked this planet for tens of millions of years. We know our species has been here for roughly 300,000 years. And we know that our industrial civilization, the one that splits atoms and sends machines to other planets, has existed for about 300 years. 300 years out of 4.5 billion. A candle flame in a cathedral of darkness. We know the geological record is incomplete. Tectonic processes recycle the ocean floor every 200 million years. Erosion, subduction, and metamorphism systematically destroy surface evidence over deep time. Less than 1% of the Earth's surface is urbanized today. The chance of finding artifacts from a civilization that occupied a similar fraction millions of years ago is vanishingly small. We know that the chemical signatures such a civilization would leave behind, carbon isotope shifts, trace metal anomalies, synthetic molecule traces, are similar to and potentially indistinguishable from the signatures of natural events. We know the PETM produced a chemical fingerprint that is the closest known ancient analog to modern industrial activity. We know its exact trigger remains debated. We know that 12,800 years ago, something catastrophic happened. Temperatures plunged, megafauna vanished, a culture disappeared. Evidence of cosmic impact continues to accumulate. We know Göbekli Tepe exists, built by people who should not have been able to build it, at a date that aligns precisely with the end of the catastrophe. We know the Sphinx carries erosion patterns that point to a wetter, older world. We know ancient maps contain features difficult to explain. We know underground cities were engineered to extraordinary depths. And we know that every culture on Earth tells the same story of a world destroyed by water and rebuilt from the ruins. None of this is proof. Let us be absolutely clear. None of this proves that a previous civilization existed on Earth before our own. The conventional explanations for each phenomenon are reasonable, and in most cases probably correct. The PETM was volcanism and methane. The Younger Dryas was freshwater disruption. Göbekli Tepe was built by exceptionally capable hunter-gatherers. The Sphinx belongs to Khafra. The Piri Reis map reflects 16th century cartographic convention. The underground cities were refugees from historical invasions. The flood myths reflect the universal experience of living near water. These explanations work. They are supported by evidence. They do not require lost civilizations or ancient catastrophes that erased all trace of a previous world. But taken together, these anomalies form a pattern of things slightly off, slightly harder to explain than they should be, slightly more connected than coincidence alone would predict. The Silurian hypothesis does not claim that a previous civilization existed. It claims that our ability to rule one out is far weaker than we assume. The geological record is incomplete. Evidence is systematically destroyed over time. And the specific signatures we would look for are exactly the kind that natural processes also produce. Our confidence in our own uniqueness rests not on proof, but on the absence of disproof. And in a system where evidence is continuously erased, absence of evidence is a fragile foundation. Does this mean something was here before us? The most parsimonious answer is no. The simplest reading of the evidence says we are the first. But the most parsimonious answer is not always correct. For centuries, the simplest explanation for the diversity of life was divine creation. For decades, the simplest explanation for continental shapes was coincidence. For years, the simplest explanation for mass extinctions was gradual climate change. Until the Chicxulub crater proved that sometimes the universe throws rocks at planets and changes everything in an afternoon. Science advances by questioning assumptions, by looking at evidence with fresh eyes, by asking whether the story we tell ourselves is the only story the evidence supports. And when you lay it all out, the evidence supports more than one story. But there is another dimension to this question. one that has nothing to do with proof or disproof, one that matters regardless of whether anyone came before us. And it is this: we are leaving a mark, right now, today. We are changing the atmosphere. We are changing the oceans. We are driving species to extinction at a rate that matches the great mass extinctions of the deep past. We are creating our own PETM. We are writing our own scar into the rock. And if we do not change course, the question future geologists will ask is not whether our civilization existed. It will be what happened to it. The Earth does not care about us. It does not care about our cities or our art or our arguments about lost worlds. It will spin and shift and erode and recycle regardless of what we do. It has done so for 4.5 billion years. It will continue for billions more. The question is not whether the Earth will survive. It always does. The question is whether we will leave anything behind that matters, or whether, like the hypothetical civilization of the Silurian hypothesis, we will be reduced to a thin, ambiguous line in the rock, a chemical whisper, a ghost in the sediment. The Egyptian pharaohs carved their names into stone because they wanted to be remembered. The builders of Göbekli Tepe created something so remarkable that it survived 12,000 years of burial. The people who told the flood myths passed their stories through so many generations that the stories outlasted the civilizations that first told them. They survived because someone cared enough to preserve them, because someone decided that this mattered, that this story, this knowledge, this memory was worth carrying forward into the dark. We remember what we choose to remember, and we lose what we fail to protect. So tonight, as the narration softens and the questions settle gently into the quiet spaces of your mind, let this thought rest beside you. Not as a weight, not as a worry, but as a kind of wonder. We are here, on a planet that is 4.5 billion years old, in a universe that is older still. We are temporary. The rock is patient, and the only things that truly survive are the things we care enough to hold on to. If someone came before us, what did they want us to know? And if no one did, what do we want to leave for whoever comes next? The earth turns slowly beneath you now. The stars drift overhead in their ancient patterns. The stone remembers what it can. The water forgets what it must. And you, here, breathing, wondering, listening in the dark, you are part of a story that is still being written. A story older than language, deeper than memory, and far, far stranger than we ever imagined. Let your eyes close now. Let your breathing slow. Let the questions float gently, unanswered, unresolved, beautiful in their openness. The earth will keep turning. The sediment will keep settling. And somewhere, in the deep silence between the layers of stone, the past waits patiently for someone brave enough to listen. Rest now. The mystery will still be here in the morning.